All right, so this is gonna be lab number 4. Okay, so let's move to the next one. Well, let's go back. So the purpose of this lab will demonstrate the use of OSPF, Open Shortest Path Forwarding Protocol, in the Dell EMC Smart Fabric OS 10. And like I mentioned in previous videos, the version for this GNS3 lab is the OS 10 Virtual 10.5.1. So OSPF enables layer 3 routing at the access and aggregation layers and distributes IP routing and reachability information of the compute throughout the autonomous system. And that's what I am going to configure. I keep on saying we, I don't know why. But anyway, I guess the more I practice, the less I'm gonna be using that crutch word. It uses the open shortest path first algorithm to find the shortest path to the destination by using the cost metrics as a primary criteria. So what are the benefits? The OSPF protocol provides layer 3 IP routing information on devices throughout the topology. The layer 3 is inherently more secure and enables one to define quality of service for all types of traffic. It uses the open shortest path first algorithm to find the shortest path to the destination by using cost metrics as the primary criteria. The higher bandwidth links, less cost, are preferred over low bandwidth links in the routing tables. But we're gonna have the same speed on all the links, so that should be helpful to do the equal cost multipathing. Let's see. In this module, you will enable OSPF, configure OSPF on all the switch nodes, and verify the configuration. Let's continue. The module begins with launching the GNS3 network emulator. Just remember, this is a network emulator and not a simulator like Packet Tracer. On the desktop, click on the GNS3 icon. So let's go to the desktop and click on that icon. And then it tells me another GNS3 GUI is already running. Okay, well, let's take a look. Oh, look at that. All right, so I don't want to continue then. I just didn't realize I had one instance running already. And this is what I did before. I just went to eat my dinner, but I already opened this project number 4. And this is how it looks like when you turn it on. So let's go to the next one. You say if the lab is not powered on, click on the green play button, which is over here. Now it's on. Let's move to the next screen. And it says to go ahead and launch switch 1 console. So let's go to switch 1. Launch the console. And let's make the font bigger. So let's go and change the settings. Let's go ahead and change the appearance, change the size of the fonts. Let's do 16 font. Much better. Let's see. Let's go to the next one. It says here, log in as admin. And it says here, after entering the credentials, the OS 10 prompt should be present and ready for command entry. If the message system is loading appears, the OS 10 prompt does not, then reload the switch. And by reloading the switch, just shut down the VM and turn it back on. the reload the switch, right click, there you go, click on the switch icon and then click stop, right? And then once stop, then you can click start. So that's good. So this one is ready to go. Let me disable the exact timeout command. Let's do configure, and then let's do no exec timeout, so that way it doesn't kick me out from the config or the exec mode. Let's see what else. Optional. Each switch has a safe configuration that can be loaded instead of entering the commands as instructed in the exercise. So let's go ahead and do that just for sake of timing. So let's go ahead and copy the configuration file on this path. The name of the file is L3 OSPF to the running configuration, then end to get back to exec mode, and then we're going to execute the write memory that will copy the running configuration to the startup configuration. So let's go ahead and do that. Let's do admin, and while we wait, well, that was fast, even though this is an emulator. So once I am at the command prompt, what I'm going to do here, I'm going to go ahead and disable the exec timeout. So let's go into config, enter not exec tab timeout. So let's go ahead and do well, over here it's already configured switch 1, which is going to be this one right there. Let me get rid of that. Let's go ahead and move to the next one. So basically what it's saying here is that we're going to go ahead and well, it's already configured. So let's do show running config compressed, so that way we can see just the pertinent interfaces. And then it's going to show us the interface VLAN 10, which for switch 1, let me see what is that. Oh, VLAN 10, okay, yeah, and it's going to be for 172.16.10.1. That makes sense. And the interface loop back for that switch 10.1.1.1/32, and it's going to belong to OSPF process 100 area 0, just like the previous lab. So we have the loop back. We have the we didn't, well, the lab didn't configure the management interface, but we configured that on previous labs. So on this one we're gonna skip it. The interface range, this is how you type interface range on the Dell OS 10.5.1, for example. You do interface range Ethernet, and then you specify the ports, right? 111.115 through 1156. No shutdown. Switch port access VLAN 1, which is the on tag VLAN. And then for interface Ethernet 112, which is going to be this one right here. It's going to have a description that says, okay, this is the link to the spine, which is this one, this link to the spine 1, okay. And then no shutdown, no switch port, right, because it's going to be a layer 3 interface. And then we enter, well, I keep on saying we must see, no. So I keep on saying we, but it's me, I. Okay, so I'm gonna enter, well, I can do it manually, or I can use the copy file. In this case, I did the copy file, so I didn't manually type it, just to be honest here. So it's 172.16.32/30, which is this one right there. No, wait a minute, this one right there. Okay, for this port going to the spine 1, part of the OSPF 100 process area 0. Let's continue here, and then it's showing us that interface 113 is linked to spine 2, and yep, it's going to spine 2. And then the IP, no switch port, right, because it's going to be a layer 3 interface. and the IP address is 172.16.7.1/30. It's going to belong to OSPF process 100 area 0. Let's see what else. Then we have interface Ethernet 114, which is this one right there, and that interface right there is going to be linked to server 1, and then it's going to be no shutdown switch port mode trunk, which is in layer 2 mode. It's going to be switch port access VLAN 1, and in that trunk VLAN 10 is going to be allowed, so that's good. Let's see what else. Router OSPF 100 is enabled. The log adjacency changes is enabled, and to that redistribute disconnected routes is also enabled, and there is some SNP information. So let's see how the switch number 2 looks like, which is the leaf number 2. And on this one, I'm not gonna do a lot of explanation. I'm just gonna do a quick check just to make sure that the config file was copied properly and nothing is off. So in this case, I'm gonna do show running configuration compressed, and let's go ahead and see. That's the port groups. Once we pass the port groups, we have VLAN 1. Then we have interface VLAN 11, which is going to be with the IP address of 172.16.11.1. Okay. Oh, I moved it. All right. So let's go back. And then loopback 0 is going to be 10.1.1.2. On switch 1, it was 10.1.1.1 because we're trying to keep some type of logic here, right? Switch 1 and this is switch 2, for example, or router 2. It's a multi-layer switch. Let's keep on going down here. Then you have the management interface is not configured on this lab. Interface range, we put a lot of the ports in VLAN 1 while others are in VLANs, in the other VLANs, right? If we keep on going down the list, then we're gonna see interface Ethernet 1.1.2, which is gonna be this one. So interface 1.1.3 in switch 2. This is switch 2. This is Ethernet 1.1.3 linked to spine 1, and then it's gonna go to 172. Oh, that interface on switch 2 is going to be 172.16.6.2, which is going to be this one right here. That makes sense. Yep. That's the IP address for that interface right there, and it's going to be part of the OSPF process. And then we have the link down to server 2, and then it's going to be a trunk going on here, allowing VLAN 11 and access VLAN 1 as well. Let's see what else. Yep, so that completes that checkup. So let's see what else the lab says here. So we did that. Please enter the following commands. Let me see if I can jump. Let's see here. So that's going to be configure the host name. That's switch 2. Okay, so let's go to switch 3. Okay, so let's go and check switch 3 by this manual. So this is switch 3, and then admin, and then it's gonna show us basically all the steps to configure. I just wanna see show running what is it, the compress. And on this one, I'm just gonna a quick glance. Okay, so I see loopbacks, I see interface management, the interface ranges to put them a lot of ports in VLAN 1, the the links, the ports going to the different leaves, to spines, and the router OSPF 100 is activated. So let's move on to switch 4. So let's go into this table of contents and go to, I think I'm getting a hang of this. So that's going to be, okay, switch 4, which is spine 2. And then let's do a quick glance. So this is switch 4. Let's do show running, in this case compress, and just do a quick, okay, that's the port groups. Okay, we have the loop back, the interface management we're not using. We have the interface range to put all the ports in VLAN 1. We have the, well, I keep on saying we. The Ethernet ports are configured for connecting to the leaves 1 and leaf 2. All the IP addresses look outstanding. The OSPF process is enabled, and everything looks peachy on this one. Okay, so let's see what else is on this lab. So once we go to switch 4, what is next? Okay, so we're gonna do some verification, and all right, so let's see if this topology is working, right? So let's go ahead and do check in switch 1. So let's go to switch 1, which is this one right there. All right, so let's do show IP. Okay, OSPF neighbor. Okay, so let's see here. Okay, so now it's checking that the neighbor is 113 and 114. So this is switch 1, and that is 113 and 114. So that is accurate. Let's go back here. Let's see what else. Yeah, so that should be. Well, wait a minute. Let me go back here. Okay, that looks a little better. Okay, it's just that by increasing the font, yeah, I just had to play with the settings. Okay, so switch 1 is showing the two neighbors, 3, which is switch 3 and switch 4. Those are the spine 1 and spine 2. The IP addresses, and it's a full. There you go. So now that we have this information, let's see what else they want us to check. The output display across all routers should be similar. So let's do this show IP OSPF topology, and we're gonna pick 2 routers. We're gonna pick 1 and 5. So let's do show IP OSPF topology, and I'm gonna compare them side by side with router 4, which is a multi-function switch. Let's see here, 4. What am I saying? 4. Okay, so let's go here and do the same command. Okay, let's do show IP OSPF routes. I think this is the one that is gonna show us. Let's drag this one. Yeah, I just don't like the way it looks. Yeah, much better. So yeah, so I'm gonna have to do this. I'm gonna just keep it open, so that way I can see it better. Oh, there you go. I think that's gonna work. Yeah. Okay, so I'm gonna do that. So these are the little tricks, right? So let's go back here and do the same. And instead of doing that, let's maximize the screen. Yeah, attaboy. Yes, sir. There's a will, there's a way. All right, so there you go. Okay, this is much better. So now I can check both routing tables, right? OSPF routes, and let's run the same command. Okay, so let's get rid of this. Let's make this smaller. Okay, there you go. Okay, so now we have two spines, so now we can compare apples to apples. So we have 1, 2, 3, and 4. 1, 2, 3, and 4. Then I have 3, 4, 6, 7, 10, and 11. 4, 3, 3, 4, 6, 7, 10, and 11 on this other one. So I just want, oh, okay. Like this one over here is 4, and this was throwing me off because this one also has a 4, but this is the 10, a 10 network, and this is the 172. So that's why I was like spinning my wheels. All right, so the more I do it, the more I'm gonna be able to be familiar, and yeah. So one thing that you go to a lab every so many months, and because you're just configuring, architecting, right, and you let other people to do the installation. So by doing these labs, I'm just gonna be able to sharpen my knives and be able to understand, not to understand, but to actually see the protocols in action, and be able to experiment and troubleshoot and detect, you know, failed links or failed switches. So that there is a lot of troubleshooting that you can do using Wireshark on this GNS3. So this is really cool. So then when I go to the lab, then I'm gonna be more efficient because I already have a ton of configuring experience just by doing this over and over and over. Let's see what else is here. So now that we were able to see all that, it says verification ping from server 1 to server 2. All right, so that's going to be the ultimate test then. So let's go ahead and do login admin. Okay, it's going. It's also a switch. Interesting. Okay. It just called server 01. Okay, yeah. Anyways, yeah, I knew that. I just forgot about it. I did the same thing on the previous lab. I used a switch as mimicking a server. So let's do ping 172.16.11.2 from server 1 to server 2, and we are pinging. It's running. So that will end this lab. So the next lab is going to be module 5. Lab 5 is going to be building a layer 3 using BGP, leaf and spine. BGP, border gateway protocol. So that's the protocol that is used widely in the internet. Let me hit Control C. It's used widely in the internet. It can be used eBGP for external, right? With each router having a different ASN number, because you are communicating with different autonomous systems, and iBGP for internal, and so that's really cool. So I'm looking forward the next lab. So I'm gonna stop here, and yep. So it was a very nice day, Sunday. Did a couple of videos, feeling pretty good.